Okay, so on page 23, we're gonna write some things down. Okay. So a dilation is either a stretch or a shrink of a figure. We're gonna take it, we're gonna make it bigger, or we're gonna make it smaller. All right. The scale factor is going to tell us how much we are going to stretch it or shrink it. Have you heard that word scale factor before? Yeah, like maybe like 2 days ago?
Yeah. Oh, that too.
Right? Yeah. Like maybe on Monday?
Yeah.
Yep. Yeah.
I actually don't remember that.
Yep. What?
I do. I remember.
Oh, Peyton remembers. My day is made. Okay. The letter we use for scale factor. Because I've asked you to put it away. Give me the book too. Give me the book too. I'm just, oh, and it's causing a distraction. You're not taking the notes. Yes, but I'm gonna keep.
Miss, this is not 4 inches.
All right, now I want you to go over to this picture right here. Stop. Okay, what would you say the scale factor is?
Number that can go to.
Okay, but in this picture, what's the scale factor? What? Okay, so Reagan is saying to go from here to here, we would multiply those numbers are like 1/2 of each other. Or you could look at it the other way. Some of those numbers are double of the other ones. So like we could say that this triangle is twice the size of the other one. Or we can say that this triangle is half the size of the other one. Okay. So the scale factor is going to tell us how much bigger or how much smaller we are from the original. Now, how are we supposed to know if it gets bigger or smaller? What did we say about K?
You got actual coins in there.
What? Not coins. What did we say about K?
It's,
how did we know it's going to stretch versus shrink?
I don't know.
You typed it.
Because it's going to get smaller. I don't know.
Mm-hmm.
No, not any answer soon.
We talked about this 10 minutes ago.
Was that even in here?
So they remember when you took that slider and you like changed K so it was big or small?
No.
Okay. What kind of numbers made our picture bigger? 100 would make it bigger. Larger than what, Tatum? If K is greater than blank, it's going to get bigger. What's that number? Guys, we just talked about it.
Okay.
That's not a number.
Look.
More than.
It's one. It's one.
It is 1. If k is greater than 1, then we have an enlargement, which is basically a fancy word for it's going to stretch. Okay? If k is less than 1, we have a reduction, which is a fancy word for it's going to shrink. For real. Bro, like, just be quiet. I'm talking to you too, Peyton.
All right, girl. That's it. I'm done with you.
Okay.
That's it. Be quiet. Peyton.
I can hear you guys.
You just know you're just you see it? Okay. Emma, what was the word you used to describe the two shapes? Yes, when we do a dilation, we are going to have similar figures. Okay, so when we did a translation, when we did a reflection, when we did a rotation, those shapes stayed congruent. But when we do a dilation, our shape is going to get bigger or smaller. So we have similar figures. And the scale factor is going to tell us in what capacity they are proportional. Okay. So I'm going to go back to this example over here. If I had the numbers 3, 4, and 5, and I wanted to get to this triangle, what would I have to do with all those numbers? If I had, okay, guess what? That is exactly what we're going to do with all of these problems. We're going to take our scale factor. We're going to take our scale factor. And we're going to multiply that number through. Okay. So, oh, shoot. I need to graph these real quick. Yeah.
Why don't you get my Christmas lights and everything on your room?
Miss Holly.
Your teacher's so boring on Christmas and Halloween.
So I very much have a tree and Buddy the Elf. So I'm not completely boring.
But where's the tree?
Yeah, for real. I love my tree.
She's about to pull out a tiny
little tree. 808.
What the heck is that?
And I know.
You have a strip of LED lights. Just a strip. Why don't you have it like more around your whole room like Barnett?
I'm not made of money.
The strip is crazy. Barnett isn't either. I mean, no teacher is.
No, you're right. Mr. Barnett was gifted with some things to decorate his room. Okay, here we go. What's our scale factor, number 1?
That's not the scale factor.
What's the scale factor?
2.
Okay, equals 2. Yes or no? Can we wait until after the 16? Okay. All right, our scale factor is 2. Hey, Marco, is K bigger than 1 or smaller than 1? Is 2 is bigger than 1, which means this is going to stretch. Okay.
Sorry.
What? Okay, so quite literally, we're going to take every single coordinate and multiply the numbers by 2. So our A coordinate is -3, 4. And since our scale factor is 2, to get A prime, we are going to take these numbers and multiply them by 2. Hey, Wes, what's -3 times 2? Hey, Peyton, what's 4 times 2?
I said 8 before him, so he didn't come back.
Here's our new A prime. Huh? Yeah. We need the coordinates and we need to plot them. Okay. Coordinate B is at 2, 1. But our scale factor is 2. So B prime. Caesar, what is B prime going to be? What's our new coordinate going to be? Well, read it. What's 2 times 2? And what's 1 times 2? All right. So 4, 2. Okay. Coordinate C is at -1, -5. If we take our scale factor and we multiply that coordinate by 2, Jacob, what's our new C coordinate going to be?
Hold on.
So what's -1 times 2?
Like I said, there are no differences.
Emma, stop. Stop. Stop.
I'm stopping.
Jacob, what's -1 times 2?
No. 2.
Positive or negative?
Positive.
What's -5 times 2? Hey, just think about it. What's -5 times 2?
-2.
All right. So our C coordinate is at -2, -10. So now I want you to plot those 3 coordinates and connect them. Okay. What do you notice about this purple triangle compared to the original one? It's bigger. By how much, Reagan? Okay, it is twice as big because our scale factor is 2. Can I do have a question or you just? Okay, this is what I want you to do. I want you to look at number 2. What is our scale factor? 4. I want you to find me the new coordinates and plot them for number 2. Ready, set, go.
They literally said I had a fever and then they used a different one and I didn't. So they sent me home. How does it make no sense? I had a fever in the first one. Then they used his mouth one. Like they put this thing in my mouth and they put it under your tongue. And then it said it.
Okay, so you're gonna take these coordinates. 4. Okay, 4. You do it? What are you gonna do with this 4? What did we do with this over here? Why not? Okay, over here, we took all of the numbers and then multiplied it by this K.
you're gonna take all these coordinates and you're gonna multiply them by 4. So what's 2 times 4?
Where the heck is the middle line?
3 times 4.
This cross thingy.
What is this? 8.
That's cute.
I know.
Oh,
I need to do this one. I need to do this one. You were already on the one. I know, and
yeah, but I have to go now.
I need to do this first.
No, but I have to know. Miss, when I did it.
I know that you need this one. But I need you to do this one.
No. You sound like a broken down car. Where they trying to start? You sound like it was 1948.
Tony, you need to be doing something for me. Tony, you need to be doing something for me.
I can't concentrate. It doesn't have a wild. Mass destroy.
Okay. Wes, what is your coordinate for P prime? 8, 12. Reagan, do you agree? Yep, if we take 2, 3 and we multiply that by 4, we get 8, 12. Good. Marco, what do you have for Q prime? 16, 12. Awesome. If we take 4, 3 and we multiply by 4, we get 16, 12. Ruby, what do you have for R prime? 12, 4. Okay. And then what's our last one? Everybody. 4, 4. Okay. Ha. Ha.
I feel like I'm Gucci man from 2006.
No, you don't.
Oh, of course I got pizza. I like it. Miss Owen?
Yeah? No. All right, here we go. Now, here's our new picture. Please make sure that when you do this, you are giving me the coordinates and the picture. Okay? Now,
Bro, I can't see because they're heavy.
Kaylee, what does the scale factor tell us in number 3? It's half, which means, Kanaya, are we getting smaller or bigger? We are going to get smaller, okay? Now, we are going to take each of these coordinates, Peyton, we're going to take each of these coordinates and we're going to multiply them by 1/2. Yes, we can. I'll show you. So our coordinate is 8, -8, right? Multiplying by 1/2 is the same as what?
Multiplying by 8, 0.
It's the same as dividing by 2, okay? So if we're multiplying by 1/2, we're cutting it in half.
Divide it by.
We're not dividing by 0.5. We can multiply by 0.5, which is the same as dividing by 2. So if you want to multiply by 0.5, that's what we're doing. All right, 8 times 0.5. What do you get?
Whoa.
4. And what's half of -8? -4. Because it's -8 cut in half. Okay. Now, if I talk about coordinate F, it is 16, -6. If I cut those in half, is she right? 8 and -3. Austin, what happens when we cut G in half? I'm asking Austin, not Peyton. What's half of 18?
9.
Yep, and what's half of -14? -7. Okay, Kale, if we cut H in half, what's half of 10? It's half of -16. -8. Oh, I can't even read that. Oh, I think I plotted that wrong. What? Okay, so does this make sense? Did our shape get smaller? Is it still a square? Did it get closer to the origin? All of those things we have talked about previously, right? If we have a reduction, it's gonna get smaller, it's gonna get closer to the origin. Okay? All right, turn to page 25, por favor. On page 25, you're gonna do numbers 1 through 5 for your homework.
I'll take what?
That's not all of them. Oh, okay. So I can have you do all of them if you really want, Peyton.